this is a real data set. I collected, sorry, I didn't collect it. I saw it from some research articles, which is published in April, maybe a couple of weeks ago. So it's quite relevant to what we have right now. Okay, so what we did, the authors of that paper did is they ran linear regression model for 6 different countries, European countries, Italy, Spain, UK, France, Germany, and also Switzerland. So the linear regression models were run for this index or maybe a metric, which is called CFR. It stands for case fatality rate. Okay, I have an explanation here. CFR stands for the ratio between confirmed cases, confirmed deaths versus confirmed cases. So it's a ratio between those two quantities. And they collect a bunch of data from Italy. For example, I'm going to zoom in Italy here. Okay, so this is the Italy we have here. So what I have here is number of cases on the horizontal axis. I also have the number of deaths for Italy as well. So there are a bunch of observations here. So that are quite a few points. Just say maybe the number of observations we collected is going to be something like a 50 or maybe 100, right? Okay, so I guess they used maybe 50 days or 100 days of information for each particular day. They're going to count how many of reported cases here, and on the same day, what is the number of deaths on that day as well. And given I have both number of cases and also number of deaths, I will be able to plot it on this graph here, right? You can see the number of cases and also number of deaths. So they run some kind of a linear regression model for each one of those 6 countries here. And so the information is given here. So there's some useful information. For example, you probably have to zoom in a little bit. So we have a model given here. We also have a R-square. If you remember what I was saying about R-square, the highest you can go is 100%, which is 1. The lowest you can get is going to be 0. So 0.99 is actually extremely high. You know, I think this is, I rarely see anything that's over 80%. This is 99. It doesn't mean the data is wrong. It just means, you know, there's a very strong positive linear relationship between the number of cases and also the number of deaths. And you can have this, you know, different set of the information for different countries as well. Okay, so the rest of the question, I have I think I have 4 questions, you know, setting up for you guys. I was asking you guys how to write out a model. Sometimes I specify 1 country. Some other questions may ask for 2 countries, right? Okay, part C is probably the hardest one. It's probably the hardest one. And D is not that easy as well. Okay, but that's okay. That's why I put you guys in breakout rooms. That's why you guys can have a discussion. And hopefully this is going to be helpful. Okay, so I like to show you how this can be written down properly, you know, just to be sure we are all using the same kind of notation. Okay, so the first question is says write out the estimated linear regression model for Italy. So we want to focus on Italy. And Italy is right here, this one. So the model is given us to here, is right here. Okay, we have to write it out. So over here, I mean, the ways the equation is being presented is different from what I used to do, because what I like to do is I want to put the slope after the intercept, but they were placing differently, right? Okay, so in any case, we can write it out. Okay, let's see. So I write it out this way. Okay, estimated depth equals to the slope multiplied by x, which is the number of x's, right? The horizontal axis over here, this is x. And the vertical axis is y, right? It is y. Okay. And the intercept is given here. It's a -1. Okay, it's a -1. Make sure you carry this negative sign with you if you want to put this one first, right? If you do want to put this one at the beginning of the equation, make sure you copy the negative sign. Okay, so the question also asks you what are the independent versus dependent variable. Okay, so what are the independent variable? What is the independent variable? What is the independent variable? Independent variable is x, right? For our cases, that's going to be number of cases. I'm going to write down here that's number of cases. And the dependent variable, that's going to be y, or explanatory variable, that's just going to be the number of death. Okay. And what is more important is the next question. This is super important. I like to ask this question a lot on the exams or maybe quizzes. What does the slope coefficient mean? So the slope here represents the 0.1094. Okay, if you watch the PowerPoint slides from this week, you probably know there are several things I look for. For example, I look for the words on average. So on average, roughly speaking, approximately, on average, okay. For every 1 cases, there is going to be 0.01094 death in Italy. Right, okay. So on average, make sure you guys have this word. It's super important. It doesn't mean for every 1 case, there will be for sure 0.1094 death. It just says on average, when you have a lot of sample, this is what the number of death we should have. An alternative explanation is going to be, you can say for every 1,000 cases, there's going to be, let's see, that's going to be 109.4 death in Italy, right? Okay, so there are different ways of saying that, but make sure you guys have on average in whatever interpretation you're going to put down there. Okay, and so over here, I also mentioned, if you look carefully, the slope coefficient is actually nothing but CFR. It gives you the ratio between the number of cases versus death, right? Do you guys see that? Okay, if you have 1,000 cases, you're gonna have this death. So the ratio between those two is nothing but 0.1094, right? Is this part clear how I solve this part? This is easy. This part should be easy. Okay, so the next one is, okay, so I'm gonna ask you guys, what is the order you have? First thing is, what metric did you guys use? What metric did you guys use? There's a very limited information. What metric did you use? Or maybe measure or index did you guys use?
R-squared.
Canon? R-squared. Benjamin said, I think it's the same as, okay, R-squared, right? R-squared. Do you guys all use R-squared? Great. Okay, so you're gonna rank them from the strongest to the weakest. Okay, so just by comparing the size of it. Okay, so what we have here, okay, so let's take a look. I think you're probably able to see Italy and Spain, they all have 0.99, and Germany and Switzerland, they all have 0.92, right? Okay, and so you can rank them this way, right? Okay, so this part is not too difficult either. Okay, so the next question we have here is slightly more challenging. Part C, okay, so you were asked what is a CFR for Germany and also Italy. And then you were asked for Italy, we know the 95% confidence interval for CFR is this, a lower bound and also upper bound. And we also know the sample size is 50 and is 50. And you were asked, what is the standard error of a CFR? Okay, so what we're gonna do is the first two questions are easy. For Germany and Italy, you can just look it up from the table. Germany, I think you just go for the intercept, which is given right here. And for Germany is this one. So the reason I want to use those two countries, what is the reason I selected those two countries? They are very, very different. Italy, as you probably heard in the news, there are a lot of fatality in Italy because of COVID-19. The CFR is indeed high. This is as high as 10%, right? 11%, as you can probably see. Whereas Germany, they were doing an excellent job, and the CFR ratio is less than 1%. It's less than 1%, right? Okay. So what I did here is I just wrote down those numbers here. So Germany is about, let's see, Italy is 10%, almost 11%, and Germany is not even 1% yet. Okay. So the next question, you were given the confidence interval and you were asked to find standard error. This is a reversed problem, The reason I say it's a reversed problem, okay, so let's go back to what we had at the very beginning of this lecture handouts. There are two tables here. The first one is a coefficient table, and the next one is a ANOVA table. we should use the coefficient table here, right? Okay, so what we have here is, okay, what we need to do is we want to figure out what is the standard error for the slope. So that means it's going to be this cell here. We have to figure out what is this quantity right here. What is that quantity here? And we were given the confidence interval formula. We were given the confidence interval. Okay, so let me go back to the question we have here. Okay, so how are we going to do it? The first thing I like to do is I'm going to write out the 95% confidence interval. Confidence interval. Okay, I think it's going to be, the confidence interval is given to be, the formula is beta 1 hat plus minus a t multiplier multiplied by the standard error. So I think the standard error is right here, the standard error, right? Okay, so let's see. So do we know what the beta 1 hat is? I think we are focused on, we are concerned with Italy here. So we actually do know the beta 1 here. The beta 1 for Italy is nothing but 0.1094. You can use the 10.94. You could also use the 0.1094. It doesn't matter. Make sure you guys always carry the percentage sign with you if you do want to use the 10.94. That's what I'm going to do. So let's see. So what I'm going to do is I'm just going to write down here 10.94% plus minus. Okay. So t multiplier, I don't know what that quantity is, and I want to figure out the standard error. So this is a question mark, right? So we have to figure out what is the t multiplier here. Okay. So t multiplier is going to be related with the degrees of freedom. So degrees of freedom is going to be sample size minus k minus 1. That's 50 minus 1 minus 1. That's 48. So as you can probably notice, this part is wrong. It's wrong. It's 48. And if you do look up the t table, which if you what is the t multiplier for degrees of freedom? That's 48. What is that t multiplier? You guys look up for me. What is that t multiplier? It's fairly close to this quantity, but it is a 2.011. Do you want me to show you how I found that number on my t table?
Can you just show real quick?
Yeah, sure, not a problem. Okay, so let's see. Again, it's gonna be a t multiplier, degrees of freedom 48, and it's a t distribution. What we are looking for is 95% confidence interval. If it's a 95% confidence interval, okay, so I'm gonna draw a curve here. T48, right here, 0. We are dealing with 95% confidence interval. Confidence interval is very important. You know that confidence interval has 2 corners here. Okay, so the area in the middle is 95%. So that means these 2 corners, they should add up to 5%, right? 5% in total. Each one should be 2.5%. And you can change this to decimals, 0.025. Okay, so I'm looking for a multiplier right here with the upper tail of a 0.25. I'm looking for here 0.025. So let's try with my t table. 48, which is given here. 0.25 is right here. So let's try is this one. Oh, this is excellent. I like this laser pointer. Right, so you guys can see it's 2.011. 2.011. Okay, so I'm going to go back to here, and as I said, it's 2.011. Once we are able to figure out 2.011, if it's a 2.011, okay, and we have this question mark we are looking for. We have a question. I'm going to erase this. I need a little bit space here. Okay, so what do we also know here is, okay, so what do we know here is we know the confidence interval is given to be, the question told us, is 10.52 and 11.37. You guys see it? Okay, so that's why we have to find that one. So that means we can write out an equation. Okay, so that means I'm going to solve an equation. Okay, well, I need a lot more space here. Okay, maybe I'm going to write it down at the bottom here. Okay, so what I have here is 10.94% plus minus 2.011. I don't know what that question mark is. I'm going to put X here. is equal to, okay, 10.52%, lower bound, upper bound 11.37%, right? Okay, so you guys can solve for this equation. Do you think you are able to do it? So I think the easiest thing is, instead of writing down plus minus, I'm just gonna change this to 10.94%. I'm gonna consider the lower bound, right? Equals to 10.52%. So you should be able to solve for x, and I think x is 0.21%. Is that what you guys get as well? Is the number 0.21?
I think we got the same one.
Oh, you got the same one. Okay, good. Okay, good. Okay, as I said, instead of trying the negative one, you could also try the plus one. Then you just equate it to be this quantity. You will get the same answer as well, right? It's going to be the same answer. So the very last question. Okay, so what we have here for the very last part is the correlation between the number of deaths and also the number of cases in UK is positive. And you were asked, are you surprised the relationship, or maybe the linear relationship is positive? Are you surprised? What do you guys think? So you want to think about what does it mean to be a positive correlation? Okay, so positive correlation means as number of cases goes up, which is the x, the number of deaths is also going to go up. You shouldn't be surprised, because the number of deaths is going to be a subset. It's going to be a small collection of the number of cases. When you have more people getting infected, there may be more people dying from this disease as well, right? Okay, so you shouldn't be surprised the relationship is positive. Okay, and I'm going to ask you another question before we work on this problem. Can you get a correlation which is 2.5? Can you have a correlation which is so positive that is 2.5?
No.
Okay, Benjamin said no. Why not?
It's between 0 and 1.
Oh, sorry. Yeah. Okay. So correlation is a very special quantity. It only measures the strength of a linear relationship. If you have a very, nicely curved relationship, it doesn't measure. It only measures a linear straight line. It could be positive, it could be negative. Okay, the correlation has to be less than 1. The highest you can get is 1. Okay, but can you also get a correlation which is minus 0.94? Can you have a correlation which is minus 0.94? Is it possible? Yes, it is possible. The correlation, it is not between 0 and 1, but is between minus 1 and 1. This is different from R square. R square is between 0 and 1. So some very important things that you guys probably want to write it out to make sure you guys have this in your note card as well. Very, very important, right? Correlation can be -1, can be as low as -1. And R square is a square term. It cannot be negative, right? You square something, it has to be at least 0. And you will ask, okay, what is the correlation? I know it is positive, but how to figure out the correlation? There is actually a relationship between correlation and R square. So R square is nothing but correlation square. Okay, I think we know for UK, the R square is 0.98. So the correlation should be the square root of that, right? It should be square root of that. Okay, and I have already mentioned this in room 2, in Ken, Benjamin, and Yuna's group. I like to also mention for the entire class, this relationship which written out here, R square equals to correlation square. This relationship only works for simple linear regression. Okay, when you guys move on to 375, that class, you're going to talk about multiple linear regression. This relationship doesn't hold anymore. It's not right. It's not appropriate. Multiple linear regression, you will not have this relationship. And the reason I can briefly mention why is that. The reason is because correlation here for simple linear regression talks about the strength of relationship between depth, which is y versus x number of cases. So it's going to be the relationship, the linear relationship between x and y. But when you have multiple linear regression, you're going to have multiple x's. It's going to be difficult to talk about which correlation you are referring to here. Are you talking about the correlation between x1 and the y, or maybe x2 and the y, or maybe x5 and the y? So it's going to be difficult. That's why this relationship doesn't hold for multiple linear regression, right? For simple linear regression, it works.